Hi everyone, welcome back to Real Estate Redefined, a web series brought to you by Cisco's Hybrid Work Center of Excellence team. My name's Murray, and I'm joined by my colleagues Ansar and Ryan in delivering this episode to you today. In our 7th episode of the web series, we will be discussing Info and SecOps. As a recap of the previous episode, we discussed the role of Catalyst Center in your environment and the features that it has to make managing your network simpler. For those returning visitors, thank you so much for continuing to watch and learn from our web series. We hope these episodes are helping you and your colleagues understand what is possible with technology and what the future may hold for the built space. For those who are just joining us for the first time, please make sure to check out our YouTube to watch the previous episodes in the series. Now let's jump in to episode 7. In today's episode, we'll focus on information security and operations in the context of modern workplaces and smart buildings. We'll be covering several key areas. First, we'll take a look at the current threat landscape, understanding the security challenges we face today. Next, we'll delve into the concept of zero trust security for the workplace, explaining how it can help mitigate these threats. We'll then explore how Cisco Identity Services Engine, or ISE, plays a role in enforcing zero trust principles. And finally, we'll wrap up with a demo showcasing Cisco ISE and Catalyst Center Trust Analytics in action. Now I'll hand it off to Ansar to cover the current threat landscape.
Thank you, Murray. The world of information technology is constantly changing. New applications, infrastructure systems, and new ways of working are redefining the security landscape. The traditional workplace is no longer limited to a single location. It has evolved into a hybrid environment with employees sometimes working from home, sometimes in the office, or from anywhere. Regardless where users are located, they require simple, seamless, frictionless, and secure access methods. Many work applications and systems are now cloud-based, and employees are increasingly using their own personal devices and mobile phones for work. Similarly, most of the organizations creating a workplace that can provide the best experience to employees, prioritizing well-being, incorporating data-driven insights, and meeting sustainability goals has become more important than ever before. To meet these demands, workplaces are being reimagined. And in this process, IoT plays a significant role by connecting and converging several new types of endpoint to the existing network infrastructure. Unfortunately, all of these advancements come with downside. Cyber attacks are escalating, with the malicious actors constantly seeking ways to exploit vulnerabilities and identify weak attack vectors. In this presentation, we will explore these trends and discuss how to secure modern workplace using Cisco solutions. Now, let's take a closer look at how the number of IT, OT endpoints in a workplace is evolving. The number of traditional IT devices is actually shrinking. This is due to factors such as increasing integration and convergence of voice and video communications. The migration of more applications to the cloud that reduces the reliance on locally deployed hardware. The implementation of bring your own device policies, allowing employees to use their personal devices for work. And most recently, the significant impact of advancement in artificial intelligence and machine learning technologies. On the other hand, the number of built-in OT devices is absolutely increasing, rapidly increasing. For example, HVAC and security systems, along with the several PoE-enabled use cases such as PoE lights, shades, IoT devices are being deployed in a modern building. At Cisco, we are at the forefront of unlocking this PoE deployment with our 90 watts UPoE plus switches. And all this growth is driven by the increased demand for data-driven insights, the need for optimization, automation, and fulfilling the ever-growing requirements of modern business operations. And also, there is an accelerated effort to create energy efficient as well as sustainable environments. As organizations nowadays decide to converge these thousands of endpoints from IT and OT domains together. It creates more potential entry points as well as increases the size of the attack surfaces for malicious actors who are actively seeking to breach the network as well as systems. Unfortunately, security features on many IoT devices are often overlooked, leaving them really vulnerable. Sometimes these devices are even placed on parts of the network that do not require level of access they might have. And additionally, many organizations, infrastructure department lack visibility into what gets connected, where it is connected, and what access these devices actually have in the operational technology area. So it is highly critical to find ways to manage and secure this growing number of IT OT endpoints to ensure there is a safe as well as a secure workplace environment. So this evolving threat landscape and changing work environment really demand a new approach to security. Traditional methods based on the network perimeters are no longer sufficient. This is where zero trust comes in. Here is a core principle. Never trust anything by default. Always verify. Every user device and application requesting access to resources need to be first authenticated and authorized before granting permission. And additionally, continuously verifying the trust is absolutely essential in zero trust security. And this zero trust initiative within an organization should be a comprehensive approach. And it should be covering 3 distinct domains. And let's take a look at what are those 3 distinct domains. First is a zero trust for the workforce. This particular domain focuses on securing your access for employees, contractors, and anyone else interacting within your systems. Zero trust ensures that they have right permissions as well as are using authorized devices. Techniques such as like the multi-factor authentications and as well as network encryptions that creates secure tunnels for users to access specific applications as well as services needed for their jobs is absolutely critical. An example solution would be Cisco's Duo as well as Cisco Secure Access Solutions. The second domain is zero trust for the workload. This particular domain focuses on securing applications as well as services running on your network, particularly addressing the east-west traffic between the applications and the data. And this work involves the workload discovery as well as like analyzing the traffic patterns and implementing technology controls. One good example is Cisco's Secure Workload Solutions, formerly known as like Tetration, that protects the workload across any cloud applications as well as anywhere. The third, but not least, is the zero trust for the workplace. It focuses particularly on securing your internal network environment, regardless of the users or device locations. While zero trust access as well as the workload security often dominates the most of the discussions, zero trust for the workplace is also equally important, especially given the focus on the hybrid work models as well as the latest cloud adoption. It extends the workplace security by ensuring trusted connections when particularly remote users connecting to an internal asset, such as like some file servers physically located on a corporate LAN. Yeah, you need to have that secured really well. And additionally, as we discussed earlier, the corporate networks are now increasingly populated by many OT or IoT devices, and the growing threat landscape targeting these devices highlights there is a critical need for the device authentication, traffic segmentations within the workplace itself. This is precisely why zero trust for the workplace is our primary focus in this presentation today. Now, the foundation of zero trust is to get a comprehensive visibility into your network environment. This actually involves identifying and authenticating all the users and devices attempting to access your resources. By understanding who and what is on your network, you can really make informed decision about your access controls. Once you get that good network visibility, you can implement segmentations. This involves you dividing your network into smaller zones based on the security needs. And these segmentations will further allow you to enforce principles of least privilege access, by granting access to the specific resources that is required for users as well as devices within that each zone. And that minimizes the potential impact of a security breach. Even with stronger security measures, threat can still emerge. A key principle of zero trust is the ability to contain that threat quickly as well as effectively being able to manage that. This might involve you isolating compromised devices, limiting some network access controls, and also quarantining them for further investigation. So by having a robust threat containment strategy, you can really minimize the damage caused by a security incident. Okay, we just talked about visibility and then applying least privilege access as the two core pillars in zero trust framework. However, most organizations fail to deploy this effectively. As you can see left side, what we expect is a neatly identified, classified, and profiled group of devices with the clear access controls between them. Sounds good, right? But in reality, often we lack the visibility to properly identify and classify all these endpoints. And many devices remain unseen and their access levels are also unknown. So how do we bridge this gap as well as achieve least privilege access? And how to run network with so many unknowns? The first and foremost crucial step is you effectively being able to identify an endpoint, collect some attributes about it, and being able to classify those endpoints. Let me invite my colleague Ryan Casey to present on how Cisco approaches zero trust security in a modern workplace environment with one of its comprehensive security tools as well as platforms.
Thanks, Ansar. So one of the challenges is securing all the infrastructure and all the connected devices that we're now providing via that unified hardware. It starts with the connectivity portion of it. Cisco wireless controllers, Cisco switching, and our access points. Being able to have common hardware across our portfolios, and being able to connect and provide those services to those edge devices. As we move up, now that we have all of these devices and this infrastructure connected, how do we secure it? And then being able to provide secure access, our guest Wi-Fi, our segmentation policies, and then posture assessments between all of that infrastructure. And as we look to be able to provide continuous monitoring, and as we look to analyze all of these endpoints, it's not so much to just connect and then be able to secure that, but to be able to do constant enforcement via device profiling and endpoint analytics, and being able to provide that back into the infrastructure and thwart any threats that happen as quickly as possible. And then as we move up, lastly, being able to have that on that unified control plane, whether it be the Meraki dashboard or through Cisco Catalyst Center. So really being able to secure and simplify all of those operations as you begin to add more and more services to that converged infrastructure. With the concept of zero trust, Identity Services Engine is one of the key pillars to be able to deliver that type of secure infrastructure. I'll take you through an example of a device coming on board, and then we can understand more of the full life cycle of zero trust. So as we look at plugging in an endpoint, whether it be a lighting node or an HVAC edge device or even a CCTV camera, the endpoint is going to request access, and then it's going to go into Identity Services Engine to be able to be profiled and then classified on what type of device that it is. From there, authorization will happen to where that device is now authorized to be able to communicate in whichever policies that have been created for that particular device. And then that device begins to be continually monitored and verified to ensure that that device is communicating as it should. So a CCTV camera is communicating as it should be, and as well as an HVAC device is communicating as it should be. This continuous verification then goes back through the entire life cycle as we continually monitor these endpoints and provide that zero trust infrastructure. So no more security through obscurity. We are continually onboarding and verifying these devices to ensure that we have a robust and secure infrastructure. Looking further into what is zero trust, let's take a look at what we have in front of us. So on the left is our endpoints, whether they be users connecting via the enterprise infrastructure, guest users, devices. So these are solutions such as lighting, HVAC, CCTV, and then things where we look at IoT end devices. So those could be temperature sensors or any type of sensors that we have in the environment. All of those edge devices connect up through the networking infrastructure, whether it be wired or wireless, and then through Identity Services Engine to be able to be profiled and then to have the policies applied to those particular edge devices. As we look on identity services, so the security aspect of it, being able to leverage Azure and your LDAP services and MFA, so the multi-factor authentication, to be able to provide that secure zero trust infrastructure. And then being able to also share that via third party. So as we look into PX Grid, being able to share that through other Radius servers or other policy servers, and then be able to have that unified front to be able to secure all the infrastructure that you are deploying within your environment. Let's take a look at the control options of Identity Services Engine. So if we look at the authentication methods, as we look on the left-hand side, we have the devices that would typically be on here, whether it be web authentication, 802.1x, VPN, MAC address authentication bypass. All of these different devices have different types of authentication methods, bringing that back into Identity Services Engine, and then having the authorization options. So applying that via ACLs, VLAN assignments, security group tags, and then being able to leverage the additional cert authorities that we have. So looking at passwords and tokens, the certificate-based authentication, single sign-on as well, and the multiple methods to be able to address all the authentication needs, and then the authorization as well to be able to authorize those devices on the network and then ensure that trust as these devices are connected to the network. 802.1x is the gold standard of authentication of devices within an environment. If we look on the left-hand side where we have our subject device, whether it be an Apple iPhone, an Android iPhone, laptop device, or an IoT device, being able to have that device be connected to the network, whether it be wired or wireless, and then being able to present either valid user credentials or a certificate-based authentication up to the Radius server to be able to be incorporated into the network. MAC address authentication bypass, or MAB, is an additional authentication method that can be used either in conjunction with 802.1x or as a fallback in the event that devices are unable to authenticate with the .1x method. In this method, we are connecting these devices to the infrastructure just as we were doing before, but now they're authenticating based on the MAC address. So as the device gets onboarded, the MAC address gets learned by the system. That MAC address now goes up into the Radius server to be able to be authenticated as an authorized user within that environment. In the event it's not, that device is now not allowed onto the network. In the event that it is, that device is now onboarded and can operate via any of the methods down below. So as we look at another authentication method, being able to authenticate devices that, let's say, are not intelligent enough to be able to do on the .1x method, but to be able to still provide that secure infrastructure for devices that are a little less intelligent than the .1x devices.
Ryan just talked about different authentication methods like Radius, MAB, or web authentication to identify and profile users and devices on the network. This information is then used to enforce access control through ICE authorization features. One of the authorization methods is dynamic VLAN, where you're placing endpoints in different VLANs based on their role. And it is also considered as one of the traditional means of limiting network access. ICE can dynamically assign devices to specific VLANs based on their user or device profiles. And this ensures that users and devices only have access to the network resources within that designated VLAN and their access control. This process involves first you authenticating the endpoint and then verifying the identity and then policy evaluations and VLAN assignment, and finally enforcement happens. Another method is access control list that can be used to control network access at the port level. They can be either downloaded to the network from ICE or be configured locally on a switch and be referenced by the ICE during the authorization process. So these ACLs provide granular control over the network access by defining rules that specify what traffic is actually allowed or denied. Typically, the downloadable ACLs are used for wired connections, while the named ACLs can be used for both the wired as well as wireless connections. The typical process involves, like I mentioned earlier, first what happens is the endpoint authentication. Then the identity gets verified. Policy evaluation happens. Then if the device meets the criteria specified in the policies, the appropriate access list controls are applied to control the device access to the network resources. Once the ACLs are applied, the traffic flowing to and from that particular device is then enforced according to the rules defined in the ACL. This ensures that only authorized traffic is allowed to pass through the network, while unauthorized traffic is completely blocked. Another method that I want to talk about is the SGT, and it is a key component of a Cisco's TrustX solutions, offering a dynamic and a scalable approach to apply access controls within a zero trust framework. This method actually enables the classification of network traffic into security groups based on shared attributes and facilitating that precise access control as well as policy enforcement. Once an endpoint authenticates and its identity is verified, it really undergoes through a classification into a security groups determined by factors such as like user role, device type, or department membership, and so on. And by assigning these tags, the devices and resources with the similar security needs are grouped together. And with the Cisco ICE serving as a central authority, will actually enforce the access controls policies based on these SGTs. When a device really attempts to connect or access resources, ICE really checks the assigned SGTs and allows or denies the access based on whether the SGTs match the predefined access controls policies or not. Earlier in this presentation, we emphasized the importance of gaining visibility into endpoints as the foundational elements for implementing least privilege access. ICE endpoint profiling is instrumental in achieving this visibility by providing that detailed insight into endpoints connected to the network. ICE utilizes various props, including NetFlow, DHCP, DNS, HTTP, Radius, Nmap, SNMP, AD, CDP, LLDP, and more to collect protocol data from each of these endpoints. By probing endpoints, what it does is ICE collects comprehensive data such as like device IP addresses, device types, network configurations, as well as communication patterns, and it enables to build that rich database of attributes, and then that can be utilized to classify devices into specific endpoint profiles, such as like Cisco IP cameras, Cisco IP phones, Apple MacBook, and Microsoft workstations, and so on. Let us shift our focus to leveraging this visibility to implement more robust segmentation and access control policies. Group-based policy, also known as GBP, simplifies the network segmentation as well as policy enforcement within SDN environments. While many companies use VLANs to split their networks, creating VLANs often involves more than you just setting them up. Each VLAN requires its own subnet and DHCP setup, and you also need to configure routing as well as access controls, which can be really a complex task, especially when you are adding new branches and you have to add several VLANs. GBP offers a solutions by allowing you to use a single data VLAN with a voice VLAN, simplifying the overall process. By tagging all the traffic from each endpoint and enforcing it with a software-defined segmentation using TrustSec or SDA, GBP makes that VLAN or subnet topology really independent and facilitating that easier scaling options. Once you define your tags and security groups ACLs, they really apply universally, not just a single locations. And this flexibility, scalability, and the topology independence are what makes the group-based policy an essential tool for modern network segmentation. The goal of trust analysis is to evaluate and monitor the risk as well as the trustworthiness of endpoints by examining various factors. And these factors include positive inputs such as like the security authentication as well as the poster details from ICE. Additionally, trust analytics identifies unusual behavior as well as threats like fake identities created through MAC or prop spoofing, vulnerabilities originating from unauthorized ports and weak passwords, and an endpoint connection to the malicious IPs via Talos integrations. It also leverages vulnerabilities as well as the threat metrics from various sources like NIST, Cisco internal data, and also partner ecosystems data to enhance the overall assessment of the endpoint trustworthiness. With that said, I will hand it over to Ryan to guide us through a demo on the Cisco Catalyst Center as well as ICE platform.
Let's go ahead and log into Identity Services Engine in our demo environment. And from here, we're brought to our dashboard where we can begin to look at the authentications, our devices, and endpoints that we have in our current environment. So we're really able to get a high-level snapshot as to what's going on in our environment. Moving through our dashboard, we'll go over to policies and our policy elements. And from here, we're able to look at the system dictionaries. So this is a quick dictionary reference for each of the endpoints, classifications, and additional information that you would have inside your environment. Going to the library conditions, this is where we're able to provide the conditions for those policies. And if we look at the multiple different authentication options, EAP, MS Chat v2, and then as we scroll down, we're able to look at what we discussed earlier, which was on the wired side and the wireless side, and then being able to authenticate based on 802.1x and the MAC address authentication bypass, or MAB. As we begin to create these conditions, this is able to look at the different types of values that are associated, and then as well as the smart conditions. So being able to look at the different types of conditions that we're going to see in each of these environments. If we click on and hover over on the MAB, we can see it gives you a brief description onto the MAB authentication and what it corresponds to in the device profiling. Now, as we go back to the actual policy sets, this is where we'll define our policies. So you see these various policies that have already been decided upon and entered into the system. And then it gives you, as we go from the policy name, the set of conditions. So when this device type equals whatever parameter that you've set up in the conditions, it's now able to provide that network access quickly and simply to those endpoints that are now connected. As we move over to Catalyst Center, we're brought to the dashboard once again, where we can go ahead and show you a high-level view of the health of your network and the devices that are on it. And as we move down into the policies and then endpoint analytics, this is where we have that constant trust verification. As we begin to look at the total endpoints that are profiled on the system, whether they've been fully or partially profiled, the profiling rules, so being able to create these rules based on the type of devices that are being profiled, whether it be static or dynamic. And then now going back, let's take a look at what it looks like if we have a device that has a low trust score. So if we go to the low trust scores, we see that there's 4 devices. I'm going to go ahead and click on the first device in this list. We can see its authentication method is wired map. From here, we see that it's a CT system, it's a GE manufacturer, and then the hardware model is a CT540. So we're able to get a real detailed view of that particular device, and then now dive into why this device has a low trust score. Looking at the authentication method, this identifies how it authenticates on the network, and it affects its actual trust score. So really looking at that full end-to-end visibility and that constant trust. And when we talk about zero trust, is being able to authenticate, being able to have that a constant enforcement and that visibility into each of these particular systems to really create that zero trust architecture and that agile and secure workspace.
Thank you, Ansar and Ryan, for going through the details on the features available from ICE that help our customers secure their environment. For all those listening, it's important to know that ICE as a solution will work with your network infrastructure, whether it is Catalyst or Meraki hardware. This includes if you have some sites using Catalyst and some sites using Meraki. Regardless of your infrastructure, ICE and Cisco's other security solutions are there to secure your network. Thank you all so much for joining us for today's episode of the web series. If you just joined us for the first time today, please make sure to check out our previous episodes on YouTube. If you enjoyed today's episode, make sure to register for future episodes of the series. Please make sure to come back next month for episode 8, where we will be covering IT and OT endpoints.